So today we have a very beautiful geometrical problem. So the question is like this way. We have 6 congruent rectangles that are arranged in a very specific pattern as you can see on this screen. Now 2 line segments are drawn joining the vertices of some of the rectangles. So because of the arrangement of this rectangle and the vertices that are connected through these line segments, a very specific angle has been formed at the intersection of this line segment that has been marked as a variable x. So ultimately the question over here is to find the value of x. So this is Anmol, and now let us see the solution. How can we find the value of the missing angle? Okay, now let us start with the solution. So the first thing that we are going to do is we are going to take the dimensions of this rectangle as variable. So therefore we are going to take the breadth, or we can say the height of the rectangle, as a variable a, and the length of this rectangle as a variable b. Now as all of these 6 rectangles are congruent to each other, each of them will have the length and breadth as equals to b and a respectively. Okay, now concentrate at this particular part of the diagram. So now look carefully. According to this particular rectangle, this side is the breadth of this rectangle, hence it would have a length a. Now according to this particular rectangle, this particular side is the breadth of this rectangle, hence it would have a length equals to a. Now look carefully to this particular rectangle. According to this particular rectangle, this complete side is the length of this rectangle, hence it would have a length b. So what we can see is that from the left hand side, the length of the same line is a plus a, that is going to be 2 times a, and according to the right hand side, the length of the same line is equals to b. And as the length of the same line is 2 times a and b, they both are going to be ultimately equals to each other. So here we have found the value of b in terms of a, and that is b is equals to twice the value of a. So instead of b, we will just replace it with its new value, that is 2 times a. So 2 times a is the new value of b. So ultimately what we have seen is that each of these rectangles have a length equals to 2 times a and the breadth equals to a. All of these 6 rectangles would have the same dimensions as they are congruent to each other. Okay, now to move forward in the solution, we need to extend some of the line segment. So first of all, look at this slipping line segment. We are just going to extend it as a straight line. Similarly, look at this line segment. We are going to extend this one also as a straight line. And at the end, we are going to extend this one also as a straight line. Okay. Now what if I tell you, when we have extended this line segments, due to this thing, we have ultimately formed 10 congruent squares.
1, 2, 3, 4, 5, 6, 7, 8, 9 and 10.
And each of these squares have a side length equals to a. Now I am just telling and you can believe it, it's not true. I have to show you a proof. So here we go. So first of all, look at this particular rectangle. These all angles are 90 degrees first of all, because they are the corners of this rectangle. The breadth of this rectangle was equals to a. Keep this thing in mind, okay? Now this angle is 90 degrees because it is the corner of this rectangle. And as we have extended this line as a straight line, by linear pair this is also going to be 90 degrees. Now in this particular quadrilateral, 3 angles are 90 degrees, hence by angle sum property this 4th angle would be 90 degrees. Now here we have a quadrilateral, all the 4 angles are 90 degrees, hence it is a rectangle. In rectangle, opposite sides are equal. So this length is already equals to a, therefore this length would also be equals to a. What about this side? So this side is ultimately the breadth of this particular rectangle, hence it would also have a length a, and as this quadrilateral was a rectangle, opposite sides were equal, therefore this length would also be equals to a. So what we can see is that this particular quadrilateral right over here is a square with a side length equals to a, and if you will just follow this pattern according to the 90 degree and all the things, you will get that all these squares are congruent to each other and each of them have a side length equals to a. So now let us utilize this thing very nicely in order to solve our problem. So first of all, what we are going to do is we are going to utilize this thing that we have extended this line as a straight line. So first of all, this angle would be 90 degrees because it is the corner of this and this square. Okay. Now this length is the side of this square, this length is the side of this square, this is the side of this square, and this is the side of this square. And each of these square have a side length equals to a, hence all this length would be simply equals to a. And therefore the complete length from top to bottom would simply be a plus a plus a plus a, that is 4 times a. So the complete length from top to bottom is simply 4 times a. Okay. Now this particular side over here is the side length of this particular square, hence it would have a length equals to a. So according to this right angle triangle that we have just formed, so first of all we have 2 times a equals to b. Let this thing as it is. Now look carefully in this particular right angle triangle, let me show you. So here we have this very nice right angle triangle. So the right angle triangle we have is like this, this and this, and here we have the 90 degree. The length of the base is a, the length of the height is 4 times a. Now what I'm going to do is I'm just going to take this particular angle as equals to theta. So over here also in the diagram this angle is equals to theta. So according to this right angle triangle, the value of tangent of theta would simply be equals to opposite upon the base. Opposite is 4 times a and the base is simply a, hence the value of tangent of theta is going to be simply 4. Okay, keep this equation as it is as equation number 1. Okay. Now what we are going to do is we are going to utilize the fact that we have extended this slipping line segment as a straight line. So first of all, these angles would be 90 degree because they are the corner of this and this squares. Okay. Now look carefully. According to this square, this length would be equals to a. According to this square, this length would be equals to a. And according to this square, this length would be equals to a. Hence the complete length from the top to this perpendicular would simply turn out to be a plus a plus a, that is simply 3 times a. Okay. So 2 times a was equals to b as it is. Now what about the length from this point to this perpendicular? So first of all, look carefully. According to this particular square, this length is going to be a. According to this particular square, this length is going to be equals to a. According to this square, this length is equals to a. According to this particular rectangle, this length is going to be 2 times b, whose length we have in terms of a, and that is 2 times a. So 2 times a, this length is a, this length is a, this length is a. So the new right angle triangle that we have just formed is like this, this and this. Okay, here we have the 90 degree. The length of the height was 3 times a, and the length of the base is simply 2 times a plus a plus a plus a, and this is simply going to be 5 times a. Okay, now what I'm going to do is I'm just going to take this particular angle as equals to alpha. So in this diagram also this angle would be equals to alpha. Okay, so now according to this right angle triangle, the value of tangent of alpha will turn out to be 3 times a upon 5 times a. A and a got cancelled out, hence the value of tangent of alpha will simply turn out to be 3 upon 5. Okay, so keep this thing as it is and let it be equation number 2. Now concentrate back on the diagram. So first of all, let me just remove the markings of this side lengths because now it's time to play around with the angles. So now look carefully. This side and this side would ultimately be parallel to each other because they are ultimately the opposite sides of this particular rectangle. So we can see that we have these two lines parallel to each other, and here is the transversal line, hence this angle would be equals to that angle. This angle already has a value equals to theta, hence that angle would also be equals to theta. Okay, so now let us utilize this thing. So now look carefully. For this particular triangle right over here, this line is a straight base. So we have a straight base and then we have a triangle. So now we can use the exterior angle property. It says that if the interior two angles are A and B, then the value of this exterior angle will simply turn out to be A plus B. So if one of the interior angle is equals to alpha and the exterior angle is equals to theta, the addition of alpha and this angle right over there should give me theta. So if you do the simplification work, you will get that the value of this particular angle, so let me just clear this thing. So the value of this particular angle you will get as equals to theta minus alpha. So now look carefully, theta minus alpha plus alpha is ultimately giving me theta. So this thing is correct. Now look carefully, this particular line is a straight line, and therefore addition of this angle and this angle would simply be equals to 180 degree. And this makes one more thing, and that is theta minus alpha is smaller than 180 degree, and also the angle x is smaller than 180 degree. This thing is very important and we are going to utilize this thing at the end. Just now keep this thing in mind that yes, x has to be smaller than 180 degree because it is lying on a straight line. Okay, now the addition of this angle and this angle would be 180 degree by the property of linear pair. Therefore theta minus alpha plus x equals to 180 degree. If I will simplify this thing in order to keep x on the left hand side, the value of x will turn out to be 180 degree plus alpha minus theta. Now what I will do is I will simply take tangent on both of these sides, hence tangent of x would be equals to tangent of 180 degrees plus alpha minus theta. Now we know this particular fact that tangent of pi plus y is equals to tangent of y, because on the Cartesian plane 180 degree means the angle pi is over here, and when we add some angle it brings us to the third quadrant, and in the third quadrant the value of tangent is positive, and as we are adding an angle to the x-axis, the ratio will remain the same. It will not change into the complementary part. Okay, so tangent of pi plus y is simply tangent of y. This is the trigonometric property. Pi radian is simply 180 degrees, so instead of pi, if I write tangent of 180 degrees plus y, this thing is also tangent of y. Okay, you can just go with anything, and here what we required is this particular property. So according to this particular property we can change the right hand side, so let us do that. So according to the property that we have just seen, the value of the right hand side will simply turn out to be tangent of alpha minus theta, and this thing is equals to tangent of x. Now we have a very nice identity for tangent of alpha minus theta, and that is tangent of alpha minus tangent of theta divided by 1 plus tangent of alpha multiplied with tangent of theta. Now remember that from the equation number 1 and equation number 2, we clearly have the value of tangent of theta and tangent of alpha. Hence we can put that values over here. So the value of tangent of alpha according to the equation number 2 is 3 upon 5 minus tangent of theta. So from the equation number 1, the value of tangent of theta is 4. Okay. Now this thing divided by 1 plus 3 upon 5 multiplied with 4, that is tangent of alpha into tangent of theta. Let me just make this thing clear. So what we have in the numerator is 3 upon 5 minus 4 divided by 1 plus 3 upon 5 multiplied with 4. And simplifying this thing will give me 3 minus 20 divided by 5 plus 12, and that is going to be simply negative 17 upon positive 17, and this thing is simply negative 1. And all of this thing was ultimately equals to tangent of x. So the value of tangent of x we have got as negative 1. So let us write it down. So tangent of x is equals to negative 1, and the angle x is in degrees. Okay. So the value of tangent of x is equals to negative 1. So now what are the possible values of x? So first of all, look carefully. So now to understand this thing, we have to again take the help of the axis. So here we have the y-axis and here we have the x-axis. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now the value of tangent is negative only in the second quadrant and in the fourth quadrant. Now to bring the angle in the second quadrant, we simply do pi minus y. So tangent of pi minus y is going to be simply negative tangent of y. And to bring an angle in this fourth quadrant, what we do is tangent of 2 pi minus y, and this thing would also be equals to negative tangent of y. Okay. Now what I will do is I will just replace y as equals to pi by 4, and I am doing this thing because tangent of pi by 4 is equals to 1. Okay. Now what I'm just thinking is to not use the radian measurement, just going with the degree measurement, because all we are dealing with is the degree measurements. So tangent of 180 degrees minus y is equals to negative tangent of y. And what if I replace y as equals to 45 degree? And why I'm doing so? Because tangent of 45 degree is equals to 1. So on the left hand side I will get negative 1, and on the right hand side I will get tangent of 135 degrees. Okay. So tangent of 135 is equals to negative 1. Now the second one that we were having was tangent of 360 degrees minus y is equals to negative tangent of y. Again I will replace y as equals to 45 degree. So on the left hand side, tangent of 360 minus 45 will give me 315 degrees, and this thing would be equals to negative 1. Okay, so here we have two angles for which the value of tangent is negative 1. So now the question arises, we need to compare tangent of x with these two values. So if I will compare this with the first value, I will get tangent of x equals to tangent of 135 degree, and hence the value of x will turn out to be 135 degree. And comparing tangent of x with the second equation will give me the value of x as equals to 315 degree. Now the question arises, the same angle cannot have the two values. Which one should we take? Because this angle has to be specific because of the pattern. So here comes the requirement of this particular data, that the angle x was lying on a straight line. It was some part of a straight line, hence it has to be smaller than 180 degree. So out of the two values of x, that is 135 degrees and 315 degrees, we can clearly say that the first value is correct because it is an angle smaller than 180 degree. The second one is correct, but from the perspective of a trigonometric equation, because we get this value of x according to a trigonometric equation. So this value is correct according to that equation, but not according to the situation from where the x is coming. What is satisfying is this particular value. Hence the value of x is equals to 135 degree, and this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below. And if it's hard to comment, or else if you want to share any kind of picture, you can email me, or else you can send it to me on my Instagram. The link is in the description.